Hey everyone, my name is Shreya Rajpal. I am the founder and CEO of Guardrails AI. And today I am going to be talking about how to rein in the wild west that is AI outputs. So any practical application of AI that you're building, anything that uses a large language model as a software component ends up being like very unreliable. And so this talk is going to be how do we take that problem and like build up practical solutions for it. Great. So let's get started. As we all know, large language models like ChatGPT are fantastic, but there's also a bunch of issues that come with them. In the past, as the reliance on LLMs has gone up, we've also seen a lot of like issues with the reliability of LLMs. So, for example, there's a lot of like these cool use cases where, AutoGPT is a fully autonomous agent that can do like any task that you throw at it. There's a lot of really amazing applications of LLMs in mental illness, medicine, sales, programming, and high tech jobs. But then at the same time, LLMs are brittle and hard to control. So issues that we see are, because of reliance on LLMs, we end up finding issues where, for example, here, ChatGPT falsely told a voter that their mayor was in jail for bribery. I think this was a pretty common, pretty popular story where a lawyer used ChatGPT in court and ChatGPT cited fake cases. Which ended up, having like, pretty negative repercussions for the lawyer. So in this talk, we're going to focus on like how do we end up getting like correct outputs from LLMs. So the issue really becomes that getting correct outputs from large language models always is pretty hard. And then common issues that people see as they're working with LLMs are hallucinations, falsehoods, lack of correct structure if you're using the output of an LLM to power like some downstream application. And the general issue ends up being that the LLM app works while you're prototyping, but it's flaky when running in production. So a very common thing that you would often hear people say is that, it was totally working. And then the first time I handed it over to somebody external to kind of test it out, it kind of failed then. A further kind of compounding of the problem is that the only tool that is available to developers as they're working with LLMs is the prompt. So you end up seeing like pretty complex prompts with a lot of prompt engineering. So for example, like I've from my own anecdote, somebody like a senior person working with LLMs ended up, writing a prompt where very, very bad things will happen if, the output from an LLM is a certain way. So all these issues kind of combine together so that the application of an LLM and in anywhere where correctness is critical ends up being like pretty challenging. So the typical applications you see that have made it into production are places where LLMs can be incorrect, but you can still move on. So for example, ChatGPT, it generates an incorrect response and you just kind of, brush it off and move on. Or like GitHub Copilot, even if the code is wrong, you can still like type it yourself. So why is controlling LLMs challenging to start with? We kind of break this down into like three techniques. So the first is controlling an LLM output via a prompt. And as I mentioned in the previous slide, this is generally pretty challenging. One of the key reasons why is that LLMs are stochastic, which means that even if you do all of the prompt engineering, and you find the best possible prompt for your application, the same input doesn't guarantee that you're going to get the same output. So even for the same prompt, running it multiple times, you're going to end up seeing some variation in the outputs. Secondly, prompts don't offer guarantees. So once again, even with all prompt engineering, even if you have very, very strict instructions for what the output of an LLM should look like, there's no guarantee that the LLM is always going to end up following that instruction. The second is controlling an LLM output by tweaking or changing the model directly. And for starters, this ends up being very expensive and time consuming to basically train on or fine tune a model. One of the reasons we've seen this like massive explosion of LLM adoption is that there's no training or fine tuning involved. And that means that a much broader audience than was initially possible can now work with machine learning tools. And this advantage goes away if we now have to, train or fine tune models. The second is that LLMs are hidden behind APIs. So even if like you're not directly training or fine tuning a model, a commercial LLM provider, might update the model version kind of like in the background without cutting an official release of the model. So that ends up, having, so as a developer, you end up having very little control over the model. And finally, the third way to do this is by combining an LLM with output verification. So this is the Guardrails kind of recommended way of doing this. And what this means in practice is that there are application-specific checks and verification programs that ensure that any LLM output is correct. And I'm going to get, I'm going to dig deeper into what that means in just a second. So here's what, a standard LLM development workflow kind of looks like. So you have like some application logic, and within that application logic, you essentially have, an LLM module where that LLM module kind of, there's a prompt that is sent to an LLM API. You end up getting like some response from that LLM API, and that response is sent back over to that application. What we recommend doing instead at Guardrails is that once you get that raw output, to send that output to a verification suite, where that suite contains, application-specific checks that ensure that any output is first vetted to make sure that it is correct and, and usable for your application. So what this may end up look like is like one check may be that there's no PII or personally identifiable information in the output. Another check may be that, there's no profanity, especially if this is something that's going to be customer facing. If you're building a commercial application, then ensuring that there's no mention of any competitors. If you're generating code, then making sure that that code is executable. And finally, if you're doing like summarization, then making sure that the summary is similar to the source text from which it's generated. So each of these ends up being like one independent check that is run on the LLM output, and then combined together, these end up building your verification suite. A more robust way of building LLM applications is for any raw output to go through this verification suite. And then only if the verification suite passes, do you then send that output back to your application. Otherwise, you can handle failures in a multitude of ways, including resending incorrect outputs back to the LLM for correction. So each of these tests ends up being, one guardrail. And, how these guardrails are actually implemented is that they may be grounded in some external system. So for example, we talked about, if there's code, making sure that that code is executable. How this is checked is by grounding the output that is generated from an LLM into the actual code runtime that you would use to run your to run that code that is generated, and making sure that there's no errors or bugs that are returned. Secondly, making sure that there may be rule-based heuristics that are implemented as part of your guardrails. So rules like never mention a competitor of any commercial application. Another way to implement a guardrail may be, using traditional machine learning methods. So creating decision trees, et cetera, that end up telling you whether an output is acceptable for a specific application or not. You can also train very high precision deep learning classifiers. So this is different from a traditional machine learning method because, these models end up being deep learning neural networks. They're typically pretty powerful and performant, but they're still much smaller than models of the likes of, ChatGPT or, any of the commercial LLMs. And then finally, you may use the LLM itself as a way to evaluate whether the output is, correct for an application. So this is in this whole framework of how to build a much more robust, much more performant AI application, what does Guardrails AI, offer you? So Guardrails AI is a fully open source library that offers, first and foremost, a framework for creating custom validators for your application. Secondly, it allows you to orchestrate the entire prompting, verification, reprompting of an LLM. Thirdly, you can use our library of many, many commonly implemented validators that work across a bunch of different use cases. And then finally, you can use Guardrails as a specification language for communicating your requirements of LLM outputs directly to the LLM. So now we're going to dig deeper into what this looks like, what using Guardrails with our recommended method of LLM development looks like in practice. So let's say that you're building a text to SQL application where your correctness criteria is making sure that you get correct SQL. So SQL that can actually run on the database, on the code, on the database without throwing any errors. So let's say you want a user to come to your application, ask a natural language question over your data. And then for that natural language question, you want to generate a SQL query where once you execute that SQL query, it should basically generate the right output. For the purposes of this example, the database that we're going to go with is a department management database. So let's say this database contains information about all employees in a department of any company. So this is a toy data set to kind of demonstrate the issue at hand. All right, so we now go back to our familiar diagram where, we have like a raw output that passes through our verification suite. And because our verification suite is, a text to SQL application, the checks that we end up looking for are making sure that, one, the SQL is executable for the database. Secondly, that there are no private tables. So let's say there's some tables that you don't want to expose to your end customer, like making sure that even if a customer asks a natural language question from that table, that information is not actually shared to the customer. And then finally, making sure that there are no risky predicates in the SQL query that is generated. So for example, even if a customer, comes on with a natural language query of like, delete all of my data, you want to make sure that there's no, drop tables query that is generated and executed. And you want to make sure that the query is correct. And then once again, only if our verification suite passes do we return the SQL code to our application. Otherwise, if it fails, we use like LLM re-asking, which is this wonderful capability of LLMs where if you give it enough context, it has the ability to self-correct. And we, utilize this ability. Cool. So let's do a run through of what this application looks like. And we're going to use a very, very toy example of building this. So let's say a user comes onto our application and has the question, which department has the most employees? This is, the prompt that will be constructed for you. So you can bring your own prompt, or you can use like some of the prompts that are pre-implemented in Guardrails for various applications. So this prompt would end up containing information of, here's information about the schema of the table. For this table, a user has a question, which department has the most employees? So generate a SQL query that contains the right, that answers this question using the schema that was previously shared. And let's say for our toy example, this is the output that we end up getting back, where we get this select name from departments query. Unfortunately, departments is a table that does not exist in our database. And so we want to make sure that, any code that we get back is executable. And because this table doesn't exist, this code won't be executable. So we want to make sure that we can correct itself. When this output passes through this verification logic here, we end up seeing that these two tests in our verification suite pass, but the SQL executable test fails. And because it fails, and because we've configured it, we essentially end up creating a prompt automatically using Guardrails that contains the original response, contains like why the response failed validation. and sending it back to the LLM. And this allows us to basically use the LLM to kind of, correct itself given enough context. And we end up getting like a new response from the LLM. So because we told the LLM in the previous prompt that this table doesn't exist and please correct the generated SQL, we end up getting a response that has the correct information here. When we pass this new response to our verification logic, it passes our verification suite. And therefore, we can, send this LLM output back to our application. Awesome. So in this walkthrough, we mostly looked at examples where anytime a verification, anytime our verification logic fails, we essentially perform re-asking. But there's a few different ways that Guardrails offers to handle incorrect outputs. So we're going to be showing like some ways that this is done in Guardrails. So let's say the response that you end up getting back from the LLM is that there's like some response that has like this tuple of name and value. And let's say the name has some transaction fee and the value is like 5. And we have like some validation on top of this where we know from our domain expertise that the value kind of must be less than like 2.5. So Guardrails offers a bunch of ways to kind of like handle incorrect output. So we're going to be looking through some of them. We're familiar with this first one, re-asking, where in re-asking, a new prompt is automatically created for you with Guardrails. This prompt contains all of the context about why an LLM response is incorrect. And then because of this prompt, we end up getting like a new LLM response that ends up having enough information. So let's say once we share this information, that value must be less than 2.5, we end up getting a new corrected value. If you don't want to perform re-asking, there's also like other alternatives where you can programmatically fix the output of any LLM. So you can essentially say, because I know that this value must always be less than 2.5, I can programmatically set my value at 2.5. This isn't possible for all the failures that we test for, but here it's easy to kind of like find a programmatic fix so we can apply it. We can also filter any incorrect values. So here, we can just filter like value equals 5 while still sharing the name. If instead your LLM output is like, let's say a paragraph or something, and only some sentences in the paragraph have like, some string that fails validation, let's say some profanity, etc. So you can filter or remove like only those offending sentences. You can also refrain from answering or share like a standard like canned response. So for example, here you can say that, sorry, no appropriate response possible because value is, greater than 2.5. You can also have no op as your corrective action. So here, no action is actually taken. Like we end up returning this output with value equals 5, but we log the fact that this specific guardrail about value failed, and then we can use this logs. So on every request, we end up having this very, very rich metadata for what passed, what failed for a specific request, and then we can kind of use this metadata to build like a very rich data set, which we can use for analytics or for improving our process. And then finally, you can also raise an exception. Great. So I wanted to share some more examples of validations that are possible with Guardrails. So, for example, one of the guardrails that you may have is never to give any financial or healthcare advice in the output. So let's say you're building like a finance application or a healthcare application, you can add a guardrail that basically ensures that your string output never contains any financial or healthcare advice. Another one may be to never ask any private questions. If you're building a commercial application, to never mention any competitors of your own company. If you are performing question answering, a very, very important guardrail is making sure that each sentence in your answer is from a verified source and is accurate for that source. You can also make sure that there's no profanity that is mentioned in the text, where you can configure, the levels. Basically, you can configure profanity for your use case. On the input guarding side, you can also make sure that there's like prompt injection protection. So prompt injection is when there's like it derives from SQL injection, where there's like inherently malicious prompts that make the LLM behave in ways that kind of goes against its rule set. And you can basically make sure that you're catching those prompt injection attacks before they're released. And then finally, never exposing the prompts or the sources that are used in your LLM. In order to learn more or follow along, you can check out the GitHub project at github.com/ShreyaR/guardrails. You can also check out our website at guardrailsai.com or follow along on Twitter at ShreyaR or at guardrailsai. Thank you so much.